My name's Hunter Keating. We are about to do our team project. We are Team 4.
What's your name?
My name is Phommachak, Phanouvong. I'm going to do the bench portion of the Team AC demo.
New school mentor.
Yes.
And state me. Hey guys, my name is Raj. My name is Raj. I'm going to show you how to do that circuit in multisim. So first we're going to start off with a blank page in multisim. Then we're going to need to add a source. For this we're going to add an AC power source, which we'll add just right here, and then we'll need a ground. So we will add that just below there as well. And then we'll close it out. We'll go to place basic and we'll add our resistors. For this source, for the circuit we're going to use a 680 ohm resistor, and we'll place this above here, and a 1.5k ohm resistor for R2. Place that there. We'll close it out, and for this we'll just make this rotate clockwise so we can have a neat circuit. So we'll just connect them all together now. Alright, and then we'll connect that, and then we'll connect the ground to the circuit. Alright, and from there we can add our voltmeter so we can measure the RMS. So we'll add one next to volt source and one for the R2 resistor. Alright, and we'll connect the positive to the positive and the negative to the negative for R2, and the same thing for the volt source. Alright, and from there we'll go ahead and open this AC up, and the RMS that we got was 6 volts. Frequency was 200 hertz. So we'll make that, and then we will change these to AC because we're measuring in alternating current, and from there we will add our oscilloscope so we can measure frequency and the time. We'll add that to the source, close to it, and then we'll add this to the ground. For B, we'll add that to the R2, and then we'll add that to the ground as well. From there, we're going to go over and add a frequency counter to the positive lead of the oscilloscope for channel A, and we'll add another to the positive lead for channel B, which is going to measure the R2 resistor. We'll double click them so we can actually see the values, and the oscilloscope as well. Alright, so now that we have it all hooked up together, we're going to hit play, and then after a little while we're going to stop it. So now we know that the RMS is 6 volts for the source and 4.128 volts for the R2 resistor. To find the peak to peak, we're going to go for each channel. We're going to switch to AC on the oscilloscope, and we're going to go through each channel to see the peak to peak for each one. We're going to make it a little bit wider so we can see it. To take these little lines, we're going to add this to, for peak to peak, we're going to add this to the minimum, and we're going to add this to the max. And then we'll get this, it's an absolute value, so it's going to actually be 16.97 volts. For the B, we will do the same thing. We'll add this to the maximum, and we'll add this one to the minimum. And this one's going to be 11.676 volts. To measure the time, we'll add from the max to the max again, so it'll be a whole cycle, which is going to be 5 milliseconds. We'll do the same thing to A, which oscilloscope channel A, and 2, which is 200 hertz, the same thing for resistor 2 in channel B. That's how to find the measurements in multi-SIP.
My name is Phommachak. I'm doing the bench portion of the demo. First, what I do is connect all these cables. Function generator cables connected to function generator. And, oscilloscope cable connected to channel 1 for the V in, and then positive and negative leads connected from D digital multimeter to positive negative ports, and then after that I connect all the negative lead, cables and all the positive lead cables, and I set my frequency, input frequency to 200 hertz, and then set the voltage in to 6 volts RMS, and then get a measurement on a channel 1 for input voltage in channel 1, which is going to read peak to peak voltage. It's going to measure to be 18 volts, and then RMS voltage measured to be 5.95 volt, and the period reading on oscilloscope to be 5.0 milliseconds, and the measure on the frequency on oscilloscope is to be 200 hertz. After that, I'm gonna disconnect V in and connect our cables to get a reading across the voltage drop across the R2, which is 1.5 kilohertz, kilo ohms, and I measure it to be 1.477 kilo ohms for R2, and R1 is we're using R1 is 680 ohms, which measure to be 665.5 ohms for R1. Now I'm disconnect all the positive and negatives. It's going to connect back all the positive and negative back to get a reading across R2. Function generator cables going to connect to positive, going to go on the positive side. So my function generator cables over here. Positive on the positive side, negative. Negative can go on the negative side. Next, I'll connect the multimeter, digital multimeter on across the resistor 2. Negative on negative side, positive on positive side, and then a channel 1's oscilloscope reading. Connect that to negative gonna go on the negative side, and positive gonna go on the positive side. Positive is negative, and I'm going to connect the channel 2 reading on R2 on the oscilloscope channel 2 port. The negative is going to go on the negative side, and the positive is going to go on the positive side. input still on frequency still on 200 hertz. Come over here on the oscilloscope reading measurement on channel. I'm gonna switch to channel 2. Turn on to channel 1. So my oscilloscope reading for the peak-to-peak voltage across R2 is 12.1 volt. And RMS voltage measure is going to be 4.08 volts. And the period measure across R2 for the R2 it's going to be 200 hertz still. And the frequency.
That's the frequency, the period.
Oh, I'm sorry, the period. The period is 5.0 milliseconds, and the frequency is 200 hertz. And that's it.
My name's Hunter Keating, and I'm about to show you the old school method of how to demonstrate voltage across the source and across the R2 resistor. So we're going to start with our voltage source, which we have 6 VRMS with 200 hertz as our frequency. And to find our volt peak to peak, we're going to use our formula VRMS times 2 over 0.707, which I have right here, which we get 16.973 volts peak to peak. And for our VRMS, we have 6 VRMS, which is comes from our voltage source. And our period, or our time, is going to come from our formula, which is 1 over frequency. And so it's going to be 1 over 200, since 200 is our frequency of hertz, which we get 5 milliseconds. And then for our frequency, we are going to use our formula for frequency, which is 1 over t. So we have 1 divided by 5 milliseconds, which we got from our time. So you could do that as 1 over 5 milli, or you could do 1 over 5 times 10 to the negative 3, which is the same as milli, which we get 200 hertz. Now, across our resistor 2, for our V2 peak to peak, we get 11.521 volts 2 peak to peak. And how we get that is from our voltage, which we get from our digital multimeter right here, 4.07, I've rounded to 4.073 for my formula, so I can plug it in to our formula, which I got 4.073 times 2 over 0.707, which is going to be 11.521 volts 2 peak to peak. So that way we have our answers for volt 2 peak to peak and our VRMS. Our time 2 is going to be the same as time 1, which is 5 milliseconds, as well as our frequency 2, which is 200 hertz. I think that's it. Alright, to measure the old school version on the digital oscilloscope, for the volts peak to peak, we would count the blocks from the minimum to the maximum, and then whatever we get, we would multiply that by 5, and that's for our volts peak to peak. And we are in channel 1 right now, but you do the same thing for channel 2, as long as you go by this number that you multiply by. And then for the time, you would measure each block and then multiply that by 1. Alright, and for channel 2, I'm going to do this pretty much the same thing as we did for channel 1 for measuring the volts peak to peak, the old school method. We're going to start at the minimum of the sine wave and then go to the maximum by counting the blocks. And then since we're in channel 2, we are going to go by this number to multiply the amount of blocks that we have by this number, which is 2. And then for time, we're going to start at the maximum of this wave to the other maximum and count the blocks and multiply them by 1. And that's the old school way on the digital oscilloscope.